Let's finish the second page of Chapter 5 and 6 test review worksheet. So number 4, evaluate the indefinite integral of x squared over square root of 1 minus x to the 6th. Okay, so we look at this and we see, are we able to use power rule? We can't. Can we split this up into individual terms? We can't. If we let the u value be the denominator inside the square root, 1 minus x to the 6th, the derivative will not produce something that will cancel out with this x squared. So we look now to our available arc-trig integral rules. And we see the square root, so we know it's either going to be arcsine or arcsecant. And the way we determine is we look inside and we see what is positive. So the positive term is the constant, and that is going to match with the arcsine rule. So if we want to use this arc-trig rule, we have to get our parentheses to show up inside the square root and get the form ready. So the form is parentheses squared minus parentheses squared. So we see if we can make some changes here and to adapt this to the form. So 1 is not going to change, so it will remain 1 squared. But x to the 6th, we want to write this as x cubed quantity squared. That way we can rewrite it in the form, and we can identify our a value and u value a lot easier. So our u value is inside, it will be the variable inside the parentheses, so x cubed. A value is always the constant, so a value is 1. We find the derivative for u, so u du over dx is 3x squared. We solve for dx, so dx is simply du over 3x squared. We make our substitutions to see if we can get our integrand in terms of a and u. So x squared stays initially, square root of a squared minus u squared, times, and then dx gets replaced with du over 3x squared. The x squared cancels out. We can pull the 3 out as a coefficient. So now we have 1/3 integral of du over square root of a squared minus u squared. Everything is in place for us to apply the arcsine rule. So we have to hold on to the coefficient, so 1/3. Arcsine of u over a plus c, so therefore 1/3 arcsine of x cubed over 1 plus c, and x cubed over 1, we can just write it as x cubed. Okay, number 5, we have the integral of -4 over x squared minus 6x plus 14. We see that this matches nicely with the arctangent rule, but if we want to get the form in the denominator to match, we would need to complete the square to get that binomial square to show up. So we complete the square first by writing this as x squared plus minus 6x plus space plus 14 minus a space. To find the value in that space, we take the b value, which is -6, or 6 divided by 2 squared. So -6 divided by 2 is -3. -3 squared is 9. So we plug 9 into the spaces and we continue factoring. So this gives us x minus 3 quantity squared plus 5. So we want this in the form of parentheses squared and parentheses squared. So x minus 3 is not going to change. It will remain as x minus 3. But 5, we want this to be in the parentheses squared, so we have to rewrite 5 as square root of 5 squared. Okay? We haven't changed the value. We've just rewritten this in the form where it'll make it easier for us to identify our a value and u value. So our u value contains the variable, so our u value is x minus 3. Our a value is the constant, so our a value inside the parentheses, so square root of 5. We find the derivative, du over dx equals 1, so therefore dx equals du. No coefficients, no variables that we have to keep track of. So let's rewrite our problem. Keep the -4, u squared, a squared, and dx gets replaced with du. So this matches nicely with our arctangent rule. The -4 is a coefficient, so we have that in front, times 1 over a arctangent of u over a plus c. Now our a value is square root of 5, so I simply replace a with square root of 5, replace u with x minus 3, and we combine this to be negative 4 over root 5, our tangent of x minus 3 over root 5 plus c. Okay, number 6, integral of negative cosecant of 2x, cotangent of 2x, all over 9 raised to the cosecant of 2x dx. So we see in the denominator here, this is 9 raised to the cosecant of 2x. Okay. I'm going to recall that we're going to try to get to, we're going to try and apply this rule here. The integral of a to the u du is equal to a to the u over ln of a plus c. Now, if we want to apply this rule, then we need this 9 to the u to be sitting up in the numerator. So we can simply move the 9 up to the top by changing the sign for the exponent. So I'm going to rewrite this problem as 9 raised to the negative cosecant of 2x times negative cosecant 2x cotangent 2x dx. Now, if we let the u value be negative cosecant of 2x, recall that the derivative for cosecant is negative cosecant of u times cotangent of u. So this should match up nicely and allow us to cancel out with this remaining trig functions. So we let our u value be negative cosecant of 2x. Remember, the derivative for negative cosecant of u is negative cosecant of u cotangent of u times u prime. So 2x's derivative becomes 2. Okay, solve for dx, we get du over negative 2 cosecant 2x cotangent 2x. We make our substitutions. So integral of 9 to the u times negative cosecant 2x cotangent 2x times, and then replace dx with du over negative cosecant 2x cotangent 2x. The trig functions canceled out. The negative also cancels out. So we should be simply left with positive. This should be a positive 1/2 integral of 9 to the u du. So this will give us, if we apply the rule given here, we get 1/2 times 9 to the u over ln of 9 plus c. So we have our solution here. This should also be a positive 9. All right, last one, number 7. We have the integral of secant of x over 2 dx. Okay, if we recall, we learned a recent integral rule for secant, which is natural log of secant of u plus tangent of u plus c. Right? So it should be obvious that our u value will be x over 2. So derivative of 1/2 x will simply be 1/2. Solve for dx. dx is 2 du. We make our substitutions. Secant x over 2 gets replaced with u. dx gets replaced with 2 du. And we can pull that 2 in front as a coefficient. So 2 times 2 integral of secant of u du. And now we simply apply the rule. So secant of u becomes natural log of secant of u plus tangent of u plus c. We have to keep that coefficient. And then finally, replace our u value in terms of x. So u gets replaced with x over 2. We get 2 natural log of the absolute value of secant of x plus x over 2 plus tangent of x over 2 plus c.